was repetitive flight plans related to repetitive flight plans. So this repetitive flight plan shall not be used for flights other than IFR operated regularly on the same day, okay, of same day or same days of consecutive weeks and on at least dash occasions or every day over a period of at least dash days. So this is the definition. So repetitive flight plan can be used for IFR flights only, provided they are operated regularly on the same day of consecutive weeks. So every Monday, okay, every Monday this IFR flight is operated, or and plus at least how many occasions? On 10 occasions. So 10 Mondays of every week or every day over a period of at least dash days. So every 10 days, at least 10 days repeatedly, consecutively, this flight, IFR flight should be operated. Only and only then you can file a repetitive flight plan. And this repetitive flight plan can only be accepted if all the ATC units that are going to fall on your route, along your route, accept this. Okay, so the very important definition that repetitive flight plans again shall not be used for flights other than IFR. So only this is exclusive to IFR flights operated regularly on the same day or same days of weeks of consecutive weeks and at least 10 occasions or every day over a period of at least 10 days. Next, question number 2. True airspeed is given, flight level is given, outside air temperature or ambient temperature is given. You have to find out Mach number. Now you can do this using CX3, but I always use formulae also. So I will show you both ways. Now we all know that Mach number equals to true airspeed divided by local speed of sound. So here true airspeed is given to us directly. Local speed of sound is not given to us. But we all know that local speed of sound equals to 39.17 square root of temperature in Kelvin. Outside temperature in Kelvin. Now outside temperature is ISA plus 15. Now so first let's find out ISA temperature at 33,000 feet is equal to 15 degrees Celsius minus 2 into 33,000. So 15 minus 66, that is minus 51. So outside air temperature will be equal to minus 51 plus 15 minus 36 degrees Celsius. Convert this into Kelvin. So minus 36 degrees Celsius equals to how many Kelvin? The formula for Kelvin temperature is degree Celsius plus 273. So how many degrees Celsius? Minus 36. So minus 36 plus 273 is equal to 237. 237 Kelvin. Okay. So local speed of sound will be 39.17 square root of temperature in Kelvin. Kelvin temperature is 237. So 39.17 multiplied by square root of 237 is 15.39. Consider 15 only. So into 39.17 is 603. So local speed of sound is 603 knots. Let's substitute these values here. True airspeed 487. Local speed of sound 603. 487 divided by 603 is 0.8. So final answer is Mach number equals to 0.8. Let's substitute this here in the CX3. Airspeed, true airspeed is what? 487. Outside air temperature in terms of Celsius is minus 36. So first convert this Fahrenheit into Celsius by pressing convert unit and now put value, what value will you put? Minus 36. 36, and then press this button plus minus in order to get minus 36. Okay. So true airspeed is given, outside air temperature is given. You got the Mach number to be equal to 0.812. So that is your answer, 0.812. And we have also got 0.8. In the calci I have got 0.807. So 0.81 or 0. Which is equivalent to 0.81. So select that option which is closest to this value. Next, question number 3. When accelerating on an easterly heading, pay attention to the word acceleration, easterly heading, and northern hemisphere. The compass card of a DRC, direct reading magnetic compass, will turn in what direction? So let's draw this. This is your northern hemisphere. This is your northerly direction, easterly direction, westerly direction. You're flying easterly heading. So that means somewhere like this. Now all of a sudden, or you have increased your true airspeed of aircraft. You are accelerated. So when acceleration happens, remember, when acceleration happens on an easterly heading in the northern hemisphere, compass card will turn to the northerly, will turn to the north pole or northerly heading, towards the northerly heading, not exact north heading, but towards it, somewhat, any heading less than 090. Okay, northerly heading. So what will be the direction of the turn? Now here, the north is to the left hand side of the east. Left to the east is northerly direction. So in order to get a northerly heading, okay, the compass card, the compass card will rotate, the compass card will rotate clockwise. Compass card will rotate clockwise. Only then this north heading will come down towards this aircraft. So that this aircraft points towards that north heading or any heading which is close to northerly direction, 020, 030, 040, whatever. So correct answer is definitely whenever you accelerate on easterly heading and in the northern hemisphere, the compass card will show the north direction. So eliminate option Charlie because it is talking about south direction. Now we are left with two options, one anti-clockwise, one clockwise. So the correct answer will be clockwise, giving an apparent turn towards the north direction. Clockwise giving an apparent turn towards the north direction. Next. Important and simple. Fuel flow 22 US gallons. Fuel flow is nothing but correction. This is your flight fuel or endurance they have asked. Fuel on board is given. Fuel. Yes. So fuel flow here is 22 US gallons per hour. Okay. Fuel on board is 83 imperial gallons and endurance they have asked. Endurance is nothing but the duration of time the fuel in your fuel tanks is going to last. 4 hours, 5 hours, whatever. So endurance will be equal to total fuel on board divided by fuel consumption or fuel flow rate. Now here fuel on board is 83 imperial gallon and fuel flow is 22 US gallon per hour. So first, our first primary job will be to Bring both the units, imperial gallon, US gallon, at a par. So equal them, to equalize them. So either convert this 22 US gallon into corresponding imperial gallon, or convert 83 imperial gallon into corresponding US gallon. So we will convert 83 imperial gallon into corresponding US gallon with the help of CX3. So let's go back. So first option, unit conversions. Go down to the volume button, this volume option, and here it's given US gallon. So we have 83 imperial gallon. So first convert US gallon into imperial gallon by pressing convert unit. Yeah. So 83 UK gallons is nothing but imperial gallon. Now convert this into corresponding US gallon. So press convert unit again until you get US gallon. So 99.68 US gallon. So 99.68 US gallon divided by 22 US gallon per hour. So endurance will be equal to 99.68 divided by 22. 4.5, that is 4 hours 31 minutes. So select that option which is closest to this value. Next, question 5. What is the source of magnetic variation information in a flight management system? Okay, what is the source of that? So I have written the answer here, correction, the options here. The option number 1 is the flight management system calculates magnetic heading and magnetic track from the flight management computer position. Option Bravo, the main directional gyro, which is coupled to the magnetic sensor flux valve position in the wingtip. Charlie, magnetic variation is calculated by every inertial reference system based on the respective IRS position and aircraft magnetic heading. Delta, magnetic variation information is stored in each IRS memory. It is applied to true heading calculated by the respective IRS. So the correct option here is option delta. Magnetic variation information is stored in each IRS memory. This is applied to true heading calculated by respective IRS. So remember this option. Next. What cost index gives the best fuel mileage? Very important. What cost index? So you have to read FMS chapter from Oxford very nicely and also solve all the questions from the Keith Williams book. So these questions are covered in detail in those books. So it's written there in that book. Cost index of 0 will give you best fuel mileage, means maximum distance in minimum fuel. Flying aircraft incurs a wide range of costs, including things like fuel. You have to spend on fuel, you have to spend on crew salaries, landing charges, ATC charges, aircraft lease or depreciation costs, right? Aircraft maintenance costs. The optimum is the best. Overall cost for any given flight depends upon the relative magnitudes, okay, of this individual cost. Sometimes fuel costs will be more than crew salaries, maintenance costs might be more than landing charges. So this charges will keep fluctuating depending on inflation. So optimum overall cost for any flight depends upon the relative magnitudes. This is very important point of individual cost. A cost index is a measure of the relation between fuel cost of flight, which is always fluctuating, and all other flight time related costs. Setting a cost index of 0 on FMS, flight management system, will cause the system to assign or designate absolute importance to fuel costs. It will therefore generate a flight profile that will produce the greatest possible range for a given quantity of fuel. Okay, like I said, best fuel mileage. Setting any higher cost index will alter the flight profile in such a manner that fuel costs increase, but other costs like flight time decreases. So a cost index is an FMS input. Remember, it's an input telling the FMS the required balance between optimizing fuel cost and sector time. So setting a fuel index or correction cost index to 0 will give you the best fuel mileage. Next, when a new load is added in one direction, the center of gravity will move in what direction? So very simple question. When you add a new load on your aircraft in a particular direction, the center of gravity will move in the same direction. It will move in the same direction. So select that option which has this particular statement. You will probably have options like the CG will move in the same direction, the CG will remain stationary, will not move, and the third option might be the CG will move in the opposite direction. So select that option in which it is given that CG moves in the same direction as the new load is added, in which the new load is added. Next, constant of cone is 0.3955. What is the latitude? Very simple. So in Lambert's chart, we know that constant of the cone, so do the Lambert chart nicely. Constant of the cone is nothing but sine of latitude. Okay. Whenever we use convergency formula in context of Lambert's charts, convergency is nothing but difference in longitudes in degrees into sine latitude. So in place of sine latitude, they always write constant of cone. Okay, that is another term for sine latitude in case of Lambert's chart. So constant of cone is nothing but sine latitude. Here it's given that constant of cone is 0.3955. So what will be the latitude at which you will find this particular value? So latitude will be equal to sine inverse 0.3955. So that latitude is going to be, use your scientific calculator, shift, then sine, press shift button first, then the sine button, and then insert the value 0.3955. You will get a value of 23 degrees 17 minutes or 23.29 something. So answer is 23 degree 17 minutes north, south, anything. So select that option which has any value closest to this value. Question number 9. Fuel on board is given, reserve fuel is there, true airspeed is given, wind component is 45 knots, headwind, outbound. Fuel consumption rate is given, you have to find distance to PNR, time to PNR. So let's draw this. Point A, point B. So going outbound, you are getting a headwind 45 knots. Okay. We need to know ground speed outbound, and then we also need to know ground speed homebound. So how will you do that? I have done many CPPNR lectures. Do watch that lectures in the RK Bali General Nav playlist. Okay. So now we have not been given any true force, so we can assume anything. So true airspeed, wind component, and ground speed. This is the table and quotes. So here I am writing. So going outbound, your true airspeed is as given in the question 440. Wind component that you are going to expect is minus 45. So ground speed will be 440 minus 45, 395. Then at PNR you are going to come back. If you choose to come back, let's say, so homebound speed will be as is going to remain the same 440. Now when you come back, okay, when you come homebound, the same wind component which was a headwind, okay, which was like a headwind going outbound, now it will be a tailwind when coming homebound. So plus 45, you are going to add that. So 440 plus 45 is 485. Okay. So outbound speed is 395, homebound speed is 485. Now distance to PNR is endurance, outbound home speed, homebound home speed plus outbound plus homebound. So we need to find endurance. Now what is endurance? Like I said before, endurance is the duration of time that the fuel in your fuel tanks is going to last. Okay, how much time it is available for use. Now endurance is nothing but fuel on board minus reserve. You're going to subtract reserve fuel from the total fuel available because that reserve fuel is not usable fuel, divided by fuel consumption rate. 15,000 minus 1,500, 2150. So 15,000 minus 1,500 is 13,500 divided by 2150. All units are going to be the same: kilogram, reserve fuel kilograms, kilogram per hour or pound per hour, whatever. So 13,500 divided by 2150 is 6 hours 16 minutes. 6 hours 16 minutes या फिर 6.3. So 6 hours 16 minutes into 395 into 485 divided by 395 plus 485. So instead of writing 6 hours 16 minutes, let's write 6.3. Multiply 6.3 into 395 into 485, 1206922.5 divided by 395 plus 485, 880. So 1206922.5 divided by 880 is 1371.5 nautical miles. So distance to PNR is 1371 nautical miles. Now time to PNR will be distance to PNR divided by outbound speed. 1371 divided by outbound speed is 395. 3 hours 28 minutes. So this is your time to PNR. So select that options which has both these values or any values closest to this.